Assalamu alaikum rahmatullah. Hi, this is Ishfaq Ahmad. My dear students, I'm expecting all of you are fine. Today, we are talking about a very common concept in your solid geometry chapter. Dear students, this is Euler's formula. Students, let me recall you that Euler formula is a relationship between the number of faces, the number of vertices, and the number of edges in a polyhedron. Let me write this first. It's a relationship between the number of faces, the number of vertices, and the number of edges in a polyhedron. Now, obviously, you will be asking for all the terms are obvious here, but there's just a term called a polyhedron, correct? Now, what is that? Let me write the definition for that also. What is a polyhedron? The students, polyhedron is basically, you can say that polyhedron is a three-dimensional solid shape. It's any 3D solid shape, not just a solid shape, but you can say that its sides should be polygonal with polygonal faces or polygonal sides. What does that mean? A polyhedron is any 3D solid shape with polygonal sides. Let me explain this with the help of this figure. This is your duster box, correct? It's you can say it's a cuboid actually. All of the sides are just as surfaces. All of the surfaces are basically polygons. That in itself, all of the sides are in itself polygons. ऐसी कोई भी फिगर जिसके sides आप मान सकते हैं as sides, they are just as polygons. They make some cubes, they make some cuboids, they make some triangles like that. Even in case of your pentagon, correct, you can say that that's a polyhedron. So if you have to put examples, for example, it's a cube, it's a cuboid, it's your prism, it's your what you can say tetrahedron. All of these are examples of polyhedrons. Now students, let's write the actual formula now. If our number of faces, if f represent the number of faces of any polyhedron, because there's a particular formula for it, if it represents number of faces, and if your v represents number of vertices and your e represents number of edges, then by Euler formula, the formula is this: v plus, or you can say simply f plus v minus e is equal to. This is your Euler's relationship connecting the number of faces, vertices, and edges. Number of faces plus number of vertices minus number of edges, you will always get 2. Or if any one of the number of faces, vertices or edges is missing, you can find using that by using this formula. The students, let's try to understand same with the help of this example again. I have been already saying that this is a cuboidal figure actually. Students, in case of this figure, which is a cuboid, we can take the case of cuboid. We can take the case of cuboid here. Number of faces, if you think of it, it's having 6 faces exactly. And if you look at the number of vertices or number of edges first, it is having 12 edges. And if you look at the number of vertices, that's V, that's actually equal to 8. Now let's simplify the left part of this equation, that is F plus V minus E, that's equal to F is here 6, V is here 8 minus E is here 12. So simply 6 plus 8 is 14, 14 minus 2 is 2. So that means your F plus V minus E was equal to 2. That's how you used this concept to, or how this formula was satisfied with the case of the cuboid. Similarly, it will be adjusted for all such figures which are actually polyhedrons. Now students, let's take one or two simple examples to understand this Euler formula more. We have an example here. We're being asked to find the number of edges in a polyhedron with 10 faces and 12 vertices. That means the number of faces and number of vertices is given. We're just supposed to find the number of edges. So let's solve it. Simple. By Euler formula, or by Euler's formula, we know that F plus V minus E is equal to 2. Correct? Now the number of faces is given, which implies 10 plus number of vertices is also given, that's 12, minus E is equal to, it implies 10 plus 12, that's 22. 22 minus E is equal to 2. Okay, yes, we actually need to find E, that's number of edges. Now what we will do, we will just transpose, this is 22 minus 2 is equal to E. That implies 22 minus 2 is actually equal to 20, that's equal to E. That means such a polyhedron will have 20 edges, which is having 10 faces and 12 vertices. So this was one simple example on this Euler's formula. Now students, let's take the second example, which is also which can be also solved by Euler's formula. This is a different situation where we're being asked to say, can a polyhedron have 12 faces, 24 edges and 16 vertices? Give reasons. So we have to look, is it such a situation possible? We will try to adjust Euler formula. If the formula is adjusting, or if there is any clash or contradiction, we will say that such a figure is not possible. As a polyhedron, we can't have such a polyhedron. So let's first check it out. Solution. As per Euler formula, we know that as per Euler formula, we have again that F plus V minus E is equal to 2. Okay, that means our left hand side should be same as right hand side. So our left hand side is F plus V minus E. After simplification, we should get it equal to be 2. Now let's see for these specific values what is going to be our left hand side. Is it exactly equal to 2 or not? It implies F plus V minus E. F is equal to number of faces is here, that's 12. Number of vertices, that's what? That's 16, yes. And number of edges, That's 24, isn't it? So 12 plus 16, that's how much? That's 28 minus 24, that's equal to 4. But our right hand side should have been what? 2. If it would have been a polyhedron, 4 is not equal to 2. That means the Euler formula is not adjusting. That means we can't have such a polyhedron. That was all I had to say in today's lecture about Euler formula. Hope that this has been useful for you. Thank you for being with me.